Hello, in this video I'll be going over how to comb through and analyze the results produced by the Steel AISC design add-on module. If you have not seen video 9, that is the first part where I go through all of the input data needed to design the Steel members in this model. I recommend watching that first, and I will link below video 9 in the description. As you can see, this is the moment frame we worked with in part 1 of video 9, and you can see the loading that's applied here along with the load cases combinations and result combinations. So we're going to go back into RF Steel AISC, and you can find that add-on module in the project navigator over here. So pretty much we're under our columns case, and all of our input data has been filled out for this case. So to start off, we can select the calculate button, and you can see that the results are produced in a split second, so they're pretty fast. And this is because all of the internal forces and loading criteria is pulled from the main program RFEM. The equations from the AISC are applied to give us our unity check, and now the result tables are given to us as well. We can view design by load case, cross-section, member, and X location over here on the left side. And with all these tables and results, don't forget that you can go over here to this button and export to Microsoft Excel if you would like, so you can comb through and organize things further. So now going to design by member, I can show you that while scrolling through, you can see that when I select different code checks, the red arrow in the background in RFEM tells me the X location of the controlling internal forces of that member. Right now we're looking at member 1. And you can see that we have all of our code checks for each chapter, chapter F, G, E, and H. For each one of these, we can go to our LTB check under cross-section type. You can see that if the cross-section is non-slender or slender, or if it's compact or non-compact. Right now we're looking at chapter F, bending about the strong axis. And down here you can see that we have all of our variables that go into play for this check. And you can also see the design ratio along with code checks on the right hand side here. This is good because we don't want RFEM to be a black box program where you're unsure of how these design ratios are coming up and which variables or coefficients are set to what. Now, if showing all this information is too overwhelming and you only want to see the governing code checks, that is okay because you can easily filter to the max design ratio in the bottom right over here. Once the max is selected, we can hit our Apply Selected Filters button, and that'll give us the governing code checks. Now on the left-hand side over here, we have also our parts list by member. This will give you the number of members, length, total length, surface area, volume, unit weight, and total weight. Now we can also click this button down here called Graphics, and that'll take us to our graphical view. And that's where we can display our results within RFEM. You can see that we are still technically in the add-on module, RF Steel AISC up here. And it also shows you which case you're under as well. But we're reviewing everything in RFEM. Over here we can select if we only want to look at our ultimate limit state design in the project navigator and view those code checks on our members. We can take a look at serviceability as well. But for our columns, we don't have any serviceability checked right now. You'll see that. For ultimate limit state design, you can see mostly where that is controlling, and that's at the top of our members where our beam connects. Now over here, we can click on RF Steel AISC, and that'll take us back into the module itself, where you can see more of those details and variables if you would like to know what's going on with our governing code checks. We can go back into cross sections up here under input data. And this is where you can optimize your cross sections. This can be done automatically. The default is set to no, but with this drop down we have a couple of options. We can choose from the current row, and this will choose any W shape from the AISC section. The other option is to choose from favorites list. Your favorites list is located in the cross section library. You can use this to only optimize from a customized group of sections. I can show you that right here by going to our cross-section library. Down here is your favorites list. You can create a new one or you can edit the current one. and pick which sections you would like to optimize. So once we hit from current row, we can hit calculate, and the program is going to give you an estimation based on the old internal forces of the old cross-section. You'll then notice the cross-section is highlighted in blue, meaning the cross-section and the module is different than the one in RFM. You can also see that statement down here in the message. So what you have to do now is right-click and export the cross-section into RFM. Then you'll want to rerun the analysis so we can get the true internal forces based on the correct stiffness. Now we can also go to our beams case, and this is where we have serviceability data set. So we can hit calculate. And now you'll see that our beam is not passing the code check for chapter L for serviceability design. We can go into our graphic view, turn off ultimate limit state, turn on serviceability, and you can see that at the midspan it is controlling at a 1.07 design ratio. We can go back into the module and get a better idea and have more details on what is going on there. So that concludes all of what I wanted to show you for the results within the RF Steel AISC add-on module. I hope this was helpful, and if you have any questions, please leave them in the comments or email us at our tech support email, which you can find in the description along with our website.